Trigonometric identities. So first we need to recall the formulae that trigonometric identities we already know. Recall. Sine squared theta plus cos squared theta is equal to 1. Then we know that tangent theta is sine theta over cos theta. Cotangent is opposite way, is 1 over tangent or cos theta over sine theta. The reciprocal ones, that secant is 1 over cotangent. Cosecant is 1 over tangent. Secant is 1 over sine. 1 over sine theta. 1 over sine theta. 1 over sine theta. 1 over sine theta, and cotangent is also 1 over tangent. So cotangent can be cos over sine, or cotangent can be 1 over tangent. Okay, and now we have a couple more. 1 plus tangent square is secant square, and 1 plus cotangent square is cosecant square theta. Is cosecant square theta. And then we will be using a couple more that we know whether the function is even or odd. So we have that sine minus theta is minus sine theta because the function is odd. Cos minus theta is plus cos theta, and tangent minus theta is minus tangent theta. Those are the trig identities we will keep using. Sine square plus cos square is 1. 1 plus tangent square is secant. 1 plus cotangent square is cosecant. Sine minus x is minus sine x or theta. Cos is only positive. Tangent is negative as well. Tangent is sine over cos. Cotangent is cos over sine. Secant is 1 over cos. Cosecant 1 over sine, and cotangent 1 over tangent. And now we would like to establish each identity. We will be proving identities using this formula that we have. So first one, A. Cos theta times, in the bracket, tangent theta plus cotangent theta. We need to show that this is equal to cosecant theta. There are two ways to do it. One way, we're gonna start with one side. This is left side of the equation. This is right side of the equation. So you start with the left side. Rearrange, use the formula that we just had until you get to the secant, until you get to the cosecant, until you get to the right side. But sometimes you can, so you start from the left side, you arrange until you get to the right side. Or you can go from the right side until you get to the left side. Depends on the formula you are proving. You cannot multiply both sides by something, because if you multiply both sides, that means your equation equality sign is true. Establish identity means check if that equality sign is true. So we're gonna go, as I said before, this is left side of the equation. And this one is right side. So I'm gonna denote left side for L and right side for R. Okay, so I'm gonna start with the left side. I copy what is my left side. So I copy the cos theta times tangent theta plus cotangent theta. I know that cosecant is 1 over sine. So I do need to change tangent and cotangent to sine and cosine stuff. I'm using my identity chart. So tangent is sine over cos and cotangent is cos over sine. So for tangent I substitute sine over cos. So this is equal to, I had cos, so I need to copy cos theta. Now in the bracket, we're gonna substitute for tangent sine over cos. So tangent is sine theta over cos theta, and plus my cotangent is cos over sine. So cos theta over sine theta. And now I'm gonna find the common denominator of those two. Common denominator of cos and sine is nothing else but cos times sine. So I will rewrite this cos theta, and I have sine theta over cos theta. I'm gonna find the common denominator, so I do need to multiply both sides, this first times sine theta and times sine theta, and then I had plus and I had cos theta over sine theta, and this one I need to multiply times cos, so this would be cos theta times cos theta. Okay, so now what I'm getting? Now I have the same common denominator. The common denominator is cos times sine, where sine times cos is exactly the same. So what we have, cos theta, and I'm gonna write as one bracket, sine times sine gives me sine squared theta, plus cos times cos gives me cos squared theta, over my one denominator, so this would be cos theta sine theta. Now I'm using the identity that cos sine squared theta is equal, sine squared theta plus cos squared theta is equal to 1 from the previous page we had, from the previous chart. We're gonna use that sine square plus cos square is 1, so this part gives me 1. So what we have cos theta times this cos square plus sine square gives me 1 over cos theta times sine theta. Okay, now we don't need the bracket, so, and this one is like over 1. So what we have, cos theta times 1 gives me cos theta, and on the bottom 1 times cos theta sine theta, cos theta times sine theta. So now we can reduce, everywhere is multiplication, we can cancel cos and cos. Cos and cos is cancelled, reduces to 1. So this is not equal to sine theta, this is equal 1 over sine theta. So this is equal to 1 over sine theta. And 1 over sine theta is nothing else but cosecant. 1 over sine theta is nothing else but cosecant. So here we go. Here is cosecant. So I ended up with my right side. So that means I started with left, I rearrange, use the formulae until I ended up with the right side. So left side is equal to right side, and the identity is established. Example B. B, we have sine u, cosecant u, minus cos squared u is equal to sine squared u. Usually we start to establish the identity with the side that is more complicated because it's easier to substitute and keep rearranging. So I'm gonna start with this left side. I'm gonna start again with the left side. So my left side of the equation is sine u, cosecant u, between them is multiplication, minus cos squared u. Now we need to end up with sine squared u. So I need to substitute. Everything to sine or cosine. We know that cosecant u is nothing else but 1 over sine. So we have sine u times cosecant is 1 over sine, and then I have minus cos squared u. This one is multiplication. Sine u is nothing else but like sine over 1. So we will have sine times 1 is sine over sine. So this reduces to 1. This cancel out to 1. So what we have? 1 minus my function cos squared u. But we do need to finish with sine squared u. We are not done yet. So what can we do? We look into the identities that we know. If you look into the first one, you know that 1 is equal to sine squared plus cos squared. So we can substitute for that 1, that's called trigonometric one, sine squared plus cos squared. In that case, the same theta, but my theta is u. So I'm gonna substitute instead of that 1, which is nothing else but the same 1, I'm gonna substitute that this is, so my 1 was sine squared u plus cos squared u, that was my 1, and now I have minus and cos squared u. I use the trigonometric one. That trigonometric one is sine squared plus cos squared, or the same angle, any angle. Okay, so now I can do the calculation. That's cos squared u minus cos squared u cancel out, and what I'm left with is just sine squared u, and sine squared u is my right side of the equation. So I started with left side and I proved that this is equal to right side. That means I established the identity. See? We have cosecant theta plus cotangent theta times cosecant theta minus cotangent theta. And we want to show that this is equal to 1. Cosecant theta plus cotangent theta times cosecant theta minus cotangent theta. So I'm going to start with the left side. Left side of the equation is those two brackets. So cosecant theta plus cotangent theta times cosecant theta minus cotangent theta. You use either the formula that this is equal to a plus b times a minus b, which is a squared minus b squared, or FOIL it, multiply them out, the brackets. So let's multiply this out. Cosecant times cosecant gives me cosecant squared. Cosecant times minus cotangent is minus cosecant cotangent. Cotangent times cosecant is cotangent cosecant, or we can switch the order, cosecant cotangent. And then cotangent times minus cotangent is minus cotangent squared. This part is basically the same with cotangent theta, cosecant theta. You can keep changing the order, right? Because it's between them is multiplication. So now minus cosecant cotangent and cosecant cotangent plus, they cancel out. So what we have, that cosecant square theta, and now I have minus cotangent square theta. You can change to sine and cosine if you wanna, and find the common denominator and end up with 1. That would be one way to do it. Or we can check the chart. What else we can find? We can check the chart what we have. So we have that cosecant square. Cosecant square is the formula 1 plus cotangent. So instead of cosecant squared, I'm gonna substitute 1 plus cotangent. So this equation is equal to cosecant squared, which is 1 plus cotangent square theta. That was just my cosecant. And I also have minus cotangent squared theta. We just use the formula that cosecant squared is 1 plus cotangent. So then the cotangent and cotangent cancel out, and I'm ended up with 1. And 1 is on the right side, so this is equal to my right side. So I prove it that left side is equal to right side. My proof is complete. Another example D. We have 1 plus tangent V over 1 minus tangent V, and we want to show that this one is cotangent V plus 1 over cotangent V minus 1. We can start from left side or from right side. We can change them to sine over cosine and find the common denominators and rearrange them, and we certainly will get this. But we can use a little bit trick, and it goes like this. I'm gonna start with the left side. 1 plus tangent V over 1 minus tangent V. Okay, I know that I need to have in the first position, I need to have cotangent. If I look into my identities, I know I can see that cotangent is nothing else but 1 over tangent. So what I'm gonna do, I'm gonna multiply this one, 1 over tangent. If I do on the top, I need to multiply the bottom, 1 over tangent V. Every term, I'm gonna multiply 1 over tangent V. I can do it because when you divide 1 over tangent divided by 1 over tangent gives you just 1. So I'm gonna multiply each and every term. So we have 1 times 1 over tangent gives me 1 over tangent plus tangent v times 1 over tangent, so this one is tangent v over tangent v. And then we have over 1 times 1 over tangent, so this gives me tangent v. And then we have minus tangent v over tangent v. Basically what I did, I divide each and every term by tangent v. It's equivalent with multiplying 1 over tangent v. And then I'm using that 1 over tangent is nothing else but cotangent. So we have cotangent v. Tangent over tangent reduces to 1. 1 over tangent is cotangent. And tangent over tangent reduces to 1. And that's exactly what I have. Okay, that's exactly my right side. So I started with left side, I ended up with the right side. My identity is proved. Example E. I have 1 plus sine theta over 1 minus sine theta is equal to cosecant theta plus 1 over cosecant theta minus 1. In this case, it's much easier to start from the right side, because this one we can rearrange until we get to the left side. So I'm gonna start with the right side. That cosecant theta plus 1 over, I had cosecant theta, and then I have minus 1. First we're gonna change cosecant. We know that this is 1 over sine. So I have 1 over sine theta, and then we have plus 1 over 1 over sine theta, and then we have minus 1. Okay, so now we can either find common denominator, of both ones, because this one is like 1 over 1. 1 over 1 like 1 over 1. So this needs to be multiply times sine, or we can multiply times sine both sides, or what we can do, we can both sides, each and every term multiply times sine. That would be even easier. So this times sine and this times sine. As before, we can do this because this is multiplying 1 over 1. So if I multiply each and every term, times sine, okay, so what I'm getting? I'm getting sine theta over sine theta plus 1 over sine theta over 1, basically speaking, but that's not needed, and over sine theta minus sine theta. Okay, so this reduces, the first fraction reduces 1 1 1 1. So what I have is 1 plus sine theta over 1 minus sine theta. and that gives me my left side. So what I did, I proved that my right side is equal my left side, so that means I established the identity. Couple more examples. F. We would like to show that 1 minus sine theta over 1 plus sine theta is equal to secant theta minus tangent theta and square it. So this identity, we start from the right side as well. It's easier to rearrange this one. So right side, we have secant theta minus tangent theta, and we do need to square it. So you always look what is at the end. So at the end, we have sine over cos. So at the end, we do need to end up with sine over cos. So that means we need to change secant and tangent into, we need to end up with sine over sine. There is no cos. Sine over sine. So we do need to end up with sines. So we do need to change those two into sine and cos, or according to the formulae what they are. Okay, so secant, we know that this secant is 1 over cos. And tangent is sine over cos. And then I have square root. So this one is already on the same denominator. So we can write as one fraction that this would be 1 minus sine theta and square it over cos theta and square it. So now I distribute the square. It would be 1 minus sine theta and square it over cos theta and cos square theta. And now be careful. You can multiply this out, but it's not worth, because I need to have on the top 1 minus sine theta. Okay, so what I'm gonna do, I'm gonna use this cos square. I'm gonna use the cos square. What do we know? Those one would be my on the sine. We know that sine square theta plus cos square theta is equal to 1. From this identity, I bring this over. I bring this sine square over. So I have that cos square theta is equal to 1 minus sine square theta. Okay, and that's what I'm gonna use. Instead, for this cos square, I'm gonna use 1 minus sine square theta. So what we have? We have the bracket 1 minus sine theta and square it. And on the bottom, I'm gonna write that this is 1 minus sine square theta. Okay, now on the bottom, we can use the formula. On the bottom, we can use the formula that this would be my a squared minus b squared. We can factor. How do we factor? A minus b times a plus b. Okay, your 1 squared minus sine squared. So the bottom part can be factored. 1 minus sine theta and 1 plus sine theta. And on the top, I'm going to copy what I have, 1 minus sine theta and square it. Okay, and now one bracket and the square can cancel out. 1 minus sine theta, cancel out with the square. So what I'm left with is exactly what I need to show. What I'm left with is exactly what I need to show. This one is 1 minus sine theta over 1 plus sine theta. And that's exactly what's on my left side. So this is equal to my left side. So I started with right side and I ended up with left side. That means I proved the identity. Another example. G. We have tangent theta minus cotangent theta all over tangent theta plus cotangent theta. Is equal to sine square theta minus cos square theta. So in that case we will start from the left side. The left side looks more complicated. So left side is equal to tangent theta minus cotangent theta over tangent theta plus cotangent theta. I'm gonna change tangent and cotangent into sine and cosine. So tangent is sine theta over cos theta, and cotangent is cos theta over sine theta, over, and tangent is tangent theta over cos theta, and cotangent is cos theta over sine theta. You cannot cancel those ones because we have addition down there, right? So now we need to find common denominator. Common denominator of those two will be cos and sine. So the first one needs to be multiplied times sine, and the second one needs to be multiplied times cos, Okay, and on the bottom the same. This needs to be multiplied times cos, and the first one times sine, So what we are getting? What we are getting is sine times sine is sine square. Then we will have minus cos times cos is cos square all over cos times sine and cos times sine, so this gives me cos theta sine theta. And then we have, oh, no, not tangent, it should be sine theta. Sine theta, not tangent, sine. Tangent is sine over cos. So sine times sine gives me sine squared. Then I have plus. Then I have cos times cos gives me cos squared. All over cos times sine theta. So now to divide by a fraction means multiply by its reciprocal. So we will flip over the fraction. So we're gonna copy the first fraction. We have sine theta minus cos theta all over cos theta sine theta. And now I have times. And I'm gonna flip the second fraction. So we have cos theta sine theta all over sine square theta plus cos square theta. So now outside this multiplication, this cos and this cos cancel out, and sine cancel out, and we cannot cancel sine square and sine square because here is plus and subtraction. But we do know that sine square plus cos square is nothing else but equal to 1. So what I am left with, this is 1, this is reduces to 1. Okay, so what I'm left with is sine theta, sine square theta minus cos square theta times 1. So that's the sine square theta minus cos square theta, and that gives me the right side. So I started with left side, I finish with right side, therefore I prove it. One more example. Okay, we have sine theta plus cos theta over cos theta minus sine theta minus cos theta over sine theta is equal to secant theta cosecant theta. Okay, so I'm going to start with the left side. I have sine theta plus cos theta over cos theta minus sine theta minus cos theta over sine theta. And I'm going to find the common denominator. I'm going to find the common denominator for those two. For those two, cos and sine, its common denominator is cos times sine. So this would be times sine times sine. But we do need to multiply everything. And this would be times cos, and this times cos. But we do need to multiply everything. So we do need to distribute this one and pay attention to the minus as well. So what we have? We have sine times sine is sine square theta. Sine times cos is cos sine. And then we have minus, and I'm going to put the bracket. Sine times cos is sine cos. And then we have cos times cos minus cos square theta. We do need to put that bracket because we do need to distribute that minus as well. All over, and now we have the same common denominator, so sine theta cos theta. Now we do need to distribute the minus, so this is equal to sine square theta plus sine, I'm going to switch the order, this is sine theta cos theta, and then I have minus sine theta cos theta, and then I have minus and minus plus cos square theta, and all over sine theta cos theta. So now this part and this part cancel out, and sine square plus cos square gives me 1, trigonometric 1. So what we are left with is 1 over sine theta cos theta. And everywhere is multiplication right here, so I can write this as 1 over sine theta times 1 over cos theta. 1 over sine is cosecant, 1 over cos is secant, and that gives me what I had to prove. Or we can change the order, that this one is secant theta, cosecant theta, which is right side, which gives me the identity. Here I use that sine square plus cos square is 1. So I have 1 minus 0, that gives me 1.